Hey kids, here's Dr. Rones with the second to the last section of Chapter 4. We have been learning about how to graph equations in a variety of different ways. We did this using a table of values. We did this finding the intercepts. We did this with slope-intercept form. And now we are going to look into the usefulness of being able to graph an equation of a line. But before we get started, just know I'm not a perfect teacher. This won't be a perfect lesson, but I sure will try to do my best. Of course, you may know a different way, and that's fine too. All right, so we are going to walk through the process of solving an equation graphically, and then once we have walked through that process, we'll pause at the end to talk about why that process works. But before that even, we are going to solve this equation here in the conventional way. So using inverse operations to isolate the variable to find the value of x. So we know reverse of a -5 is a +5. What I do on one side, I do to the other. 2x is 6. You can divide by 2 to get x is 3. And we know that we can show that our answer is true by substituting the value of the variable in for the variable. So 2 3s is 6, minus 5 is 1. Here is another way that you can prove the value of x, and you can see how it relates to a graph. I'm switching pens here, sorry it's a little noisy. I got brand new pens. I'm pretty excited about that. All right, sorry, sidebar. All right, so there's 3 steps to this process. I'm just going to give you the steps without a rationale or a justification first, because I would like for you to be thinking about why this works rather than me just tell you. So step 1 is to write the equation in ax plus b equals 0 form. This feels like breaking an equation. So you want the variable and the constant to be on the same side, equal to 0. So the way that you would do this is, here's the constant, here's the variable, here's the constant, and we want this equal to 0. The reverse of a positive 0, what I mean to say is the inverse of a positive 1 is a -1. What I do on one side, I do to the other. So I'm left with 2x minus 6 is 0. Now we have set up to this point that this is like breaking an equation, like having a one-sided teeter-totter, right, with having this 0 up in the air. But what we can do with that is to rewrite this equation, now that it's in this form, as an equation in slope-intercept form, in y equals mx plus b form. Basically, we're subbing y in for that 0 that we just had. So 2x minus 6 is now y. Or if you can flip it around, y equals 2x minus 6. We'll talk about why. Right now we're just doing the process, and we'll talk about why it works. Okay, now that we have an equation in slope-intercept form, we can graph it to find the x-intercept, and that's going to be the value of x, and hopefully that agrees with what we found at the beginning of our lesson, which was 3, I believe. So a -6 intercept, 3, 4, 5, 6 is here, and a slope of 2 is the same as 2 over 1, so up 2, right 2, up 2, right 2. I can do this a number of times. And I want to stop right here. So this line is going to go here. And you'll notice that it crosses the x-intercept at 1, 2, 3. And that is no coincidence. That is proving the solution of the equation graphically. So another way to say it is, if you follow this process and you graph the line, it should go through that point on the x-axis. That would be the solution if you solved this the typical way. Okay, but why does it work? Why does it work that we can substitute y, that we can make this equal to 0 and then substitute that y in for 0? Well, we're trying to find the value of x. We're trying to find where the line goes through the x-axis. Do you remember what we learned about finding the intercepts? because wherever this line crosses the x-axis, that would be the x-intercept. Think about it. Do you remember how we find the x-intercept? Yeah, we do that by subbing in 0 for y, and then continuing to solve. Another way to think about it is if y is 0, that means there is no vertical movement from the x-axis, right? The intercept can be anywhere along here, but no matter what, it's always going to be at the 0 point of the y-axis. So the coordinate of the x-intercept in this case was 3, 0, 3, 0, which satisfies the equation that we started with because we had x is 3 here. Okay, so if we sub in 0 for y, or if we make an equation equal to 0 first and then sub in the y for 0, we can then find where the line crosses the x-axis to verify that our initial answer was correct. It's a short and sweet lesson, but isn't it cool? I really like looking at the different layers of how what we are learning work together. Okay. Well, a really good way to make sure that you really understand what you're doing is to do some practice on it. We'll keep this one short in the start, but we're going to do actually quite a lot of practice in the end here. I think it's good. It's a good culmination of everything that we have been doing so far. So this top section says to identify the x-intercept of the line whose graph is shown. So take a moment and see if you can find the x-intercept in number 1. The line crosses the x-axis here, and the coordinate for that is 4, 0, and you would continue that with the others. The next section says to match the one variable equation with its related function, and I will tell you that for some of these there are more than one option, so you may need to solve this in more than one way. So I recommend for each of these that you rewrite them, 3x equals 6. And remember, step 1 is to rewrite the equation so that it is equal to 0. Subtract 6, subtract 6, so 3x minus 6 equals 0. Or we could say 3x minus 6 is y. Or if we're going to rewrite it in slope-intercept form, y equals 3x minus 6. So this is our equation in slope-intercept form. So I should be able to find it among these solutions. So let's look. Oh, but look, none of them seem to match. Well, that is because we can rewrite this in a different way. I'm just going to, sorry, I'm running out of space real estate here. 3x equals 6. Same one. This is still a. Probably should have done this on a different piece of paper. Okay. Here we subtracted 6. Let's do the opposite. Let's subtract the 3x and make it equal to 0 that way. So 0 is negative 3x plus 6. Still put in the y. Okay, so this is a different version of it. And you'll notice that each of the values now are just the inverse, right? Let's see if that's an option. Nope. Oh, here it is. Negative 3x plus 6. So this is a. Or you can say that a goes with 3. Okay. So both of these are a rewrite of that equation. My question for you is, I mean, they're obviously different equations. This one will have an intercept of negative 6 and a positive slope. This one would have an intercept of negative 6 and a positive 3. This is a positive 6 and a negative 3. They're going to cross. They're going to make a big X. They're different. Why do they both work? Well, because both of these equations, when you graph them, they will intersect at the same point. The solution here, if I divide each side by 3, would be x is 2. So if I graph this equation, here is, sorry, I'm giving you a little bit more information than you probably care to know, but this is interesting to me. If you were to graph this equation, say this is negative 6, and you do a positive 3, right 1, positive 3, right 1, and it goes through like that. it's going to go through at 2. And if you do the same thing here, if this were positive 6 and a negative 3 slope, down, down, it's going to go through here. So they are different in the sense that they go in opposite or inverse directions, but they both intersect at positive 2. Wow, I went on a crazy long tangent there, but I get excited about how these things all work together. So can I just back that up for your practice? So sorry. Rewrite your equation equal to 0. Sub in y for 0, just like step 2 in our notes. Rewrite the equation and determine which of the options it goes along with. If you don't find an option, rewrite the equation the opposite way and see if that option is available to you. You can either write the letter with a number or the number with a letter. And that's that. Sorry. I got to be a little extra. Okay, I'm going to fold my paper. Can't get my tripod quite right today, so I keep bumping into it. Okay, so now we are going to write this equation in ax plus b equals 0 form, and then write this in slope-intercept form. Now, if you remember from the top, you could probably have, well, not probably, you could have 2 different solutions that are accurate. Now, I would think for like one like number 10, when you're doing this, 5x plus 2 equals 7, I would think it'd be much easier to subtract the 7 than to subtract the 2 and the 5x. So I would think that most people would have this equation. See, this would be 0, 7, y for 0, there's the y. I would think most people would have this for a final solution for number 10. Most people would subtract this 4x over. Most people would subtract this 9 over. Be careful. Remember that x's come first. But down here in 14, you may have some people who subtract the 5x and add the 4. You may have others that add the 6x and subtract the 1. So that could work out in 2 different ways. You only need to write down 1, because we all know that the point of this is to find the intercept of the x-axis, and both of those equations are going to go through the same place. Okay, this is where it all comes together in a beautiful mathematical unicorn paradise wonderment. Okay. These instructions are opposite. I truly don't care what order you do this in, as long as you do both parts, and I want to see both parts. So the first part is to solve the equation algebraically. So for example, subtract 3, 5x is negative 5 divided by 5 rounds. Seriously, when are you going to learn to use lined paper? Okay, obviously you should use lined paper for this because I just made a train wreck of my worksheet. Okay, that's the first part, and on the front of the worksheet, I want to see x equals negative 1. Then I would like you to rewrite the equation to solve by graphing. So 5x plus 5 equals 0. Or you could say 5x plus 5 equals y. Or you could say y equals 5x plus 5. And so that's the other half that I want to see on the front. So I want to see the solution for x and the equation. And from there, I would like you to please graph these on a coordinate plane. Remember to please number them. And I would like to see the point where this equation intersects at negative 1 on the x-axis. It's a way for you to check yourself and the accuracy of your solution. If it doesn't intersect at negative 1, that either means that you were incorrect when you solved algebraically, or you're incorrect when you rewrote the equation. Okay, there are 12 of these for you to do, and I think they're a fabulous practice for you. And I know that it's a lot of work, but I strongly recommend it. I will give you kind of a heads up. Some of them, I just wrote on myself. I don't want to give too much away, but I want to indicate a few of these. So these 5 questions have something in common. I don't want to tell you what that thing is. Okay, I am going to tell you because I'm being a little bit abstract. These 5, your solution for x will be a fraction. So when you graph this equation, after you write the equation in slope-intercept form, don't be alarmed if the line does not go through the grid lines perfectly, because if the solution for x is a fraction, then the line is not going to go through a grid line. It's going to go through a partial. So, sorry, I really didn't want to give that to you. But if you're working from home or independently, I don't want you to get stuck either. So, great. We will save number 31 for a time when we can all talk together. If you have any troubles at all, do not hesitate to contact me. Always happy to help. Thanks a bunch, and yeah, we'll catch you in class.